Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at differentiation, specifically the connected rate of change. This is part 11, and make sure to check out all the parts prior to this part. And also, subscribe so that you don't miss out on any of our future uploads. Check out our playlists that are currently available. Recall from the rates of change from video part 10 from the differentiation list, we learned that dy dx is equal to dy dt times dt dx. This would imply that dy dt is going to be equal to dy dx times dx dt, where the dx dt is equal to 1 over dt dx. And also, dy dt represents the rate of change of y with respect to time, or simply the rate of change of y. And also, dx dt would represent the rate of change of x. Now, with this in mind, let us take a look at the first example for the day. Example 1. Water is poured into the hemispherical bowl of radius 5 centimeters at a rate of 3 pi cubic centimeters per second. After t seconds, find the volume of water in the bowl, v cubic centimeters, and that is given by v is equal to 5 pi h squared minus 1 over 3 pi h cubed, where h centimeters is the height of the water in the bowl. So A, find the rate of change of h when h is equal to 1. So the solution. We know that the rate of change of h is dh dt from the notes we have on the left. We are also given that the rate of change of v, the volume, is dv dt, which is equal to 3 pi. Then the dh dt is going to be something times dv dt. So we are given the dv dt and we are trying to find the dh dt. So we know that if we have a dv in the denominator, that will cancel out with the dv that we currently have. Then we must have something in the numerator so that in the end we get dh dt. So that then would be dh dv. So we see that the dv's will cancel out. And where we had the dv's, we now have a 1. So dh times 1 is dh over 1 times dt, which is dt. So we get dh dt. Great, then, with that in mind, we are going to find the dh dt with what we know. And also, take note, since we don't have the dh dv, we know that the dh dv is going to be given by 1 over dv dh. Now that would now take us to the v. We know that the v that we're given, which is the volume, the formula for the volume, is 5 pi h squared minus 1 over 3 pi h cubed. Then we can get the dv dh from here, where we are differentiating v with respect to h, so that we get 10 pi h minus pi h squared. Now with that, we are going to flip it over, or we are going to divide that into 1, which is the same as flipping that over. So what was the denominator becomes the numerator, and what was the numerator becomes the denominator. Therefore, the dh dt is given by the formula, and where we have dh dv, we are saying that we are going to have 1 over dv dh since that is something we know, times the 3 pi, because that was the dv dt that we were given. And of course, simplifying further, we are going to get dh dt is equals to 3 over 10h minus h squared. Right, so now that we have the dh dt formula, we are going to now look at it when h is equals to 1. So now when h is equals to 1, wherever we have h, we are going to substitute that with the 1, so that we have 3 over 10 times 1 minus 1 squared, and that would give us 1 over 3 centimeter per second. And that's the answer to part A. Similarly, part B is going to become easier, because what we have already is the dh dt, which is the rate of change of h. But now all we have to do is substitute for the h with a 3. So doing so, we are going to get dh dt is equals to 3 over 10 times 3 minus 3 squared is equals to 1 over 7 centimeter per second. And that completes part B of the problem. Now let's take a look at example 2. Paint is poured onto a flat surface and a circular patch is formed. The area of the patch increases at a rate of 5 square centimeters per second. A. Find in terms of pi the radius of the patch after 8 seconds. So the solution: area of a flat circular patch is given by A is equals to pi r squared, where r is the radius. Now also, we are given the rate of change of area, which is dA dt, which is equal to 5 square centimeters per second. After 8 seconds, we can find the area, and the area will be given by dA dt times 8 seconds. And we know what our dA dt was. That was a 5 square centimeters per second times 8 seconds. So that is going to give us 40 square seconds. And also, since A is equal to pi r squared, and that being equal to 40, we can solve for r. Firstly, we divide throughout by pi so that we get r squared as 40 divided by pi. And taking the square root on both sides, then we have r being the square root of 40 divided by pi. Therefore, the answer becomes, in a simplified manner, r is equals to 2 times the square root of 10 divided by pi centimeters. Great then. So that is how we would find the radius of the patch after 8 seconds in terms of pi. Moving on to the B part, the rate of increase of r, we know that that would be given by dr dt. Also, since we are also given the dA dt, we are going to find the missing part. So we know that the dr dt is something that we are looking for, and then we are going to multiply that in order to get the dA dt. And take note, we need something that would cancel out with the dr. That would be in the denominator. So we know that in the denominator of the something that we're looking for should be a dr. And at the top, we must have a dA. That is how this becomes dA dt. So that missing part would be dA dr. As we can see, the dR's can cancel out so that we are left with dA dt, which is what we have on the left-hand side. With that then, we can find the dr dt by making the dr dt the subject of the formula, so that that is equal to dr dA times dA dt. Now, simply substituting for the dA dt, but remember, we don't know what the R, the A is as of now, but what we know is A is equals to pi R squared. Now with that, we are going to differentiate A with respect to R so that we get the A, the R, which is equal to 2 pi R. Now that we can flip it over so that we get the R, the A, by simply taking that and dividing into 1. So meaning that the 2 pi R would have to be divided into 1 in order for us to get the R, the A. Great then. So our dr dt becomes 1 over 2 pi R times the dA dt, which was 5. So multiplying throughout, we are going to get dr dt is equals to 5 divided by 2 pi R. So with that, we also have after 8 seconds, we know what the value of R is after 8 seconds. And this is the solution that we got from part A. So substituting for the R that we obtained in part A into this particular R in the dr dt, we are going to have this bit over here. Then of course, we can simplify what we have right there further. And in doing so, we are going to get dr dt is equals to 5 times square root of 5 divided by 4 pi times root 10. So that will be our answer. So if you have made it thus far, I say congratulations to you. And I leave you with the following task. Make sure to attempt it and also post in your questions so that we help each other out. And if you want me to verify your answers, make sure to post them in as well. Thank you so much for watching Numbers Simplified. And remember, God loves you.